the terms for you. They tell you here what has to be the answer. So I think everybody gets the idea that we've got a complement. But what happens is that you end up typing the answers in backwards. So I just want to make sure that we kind of understand this. It says use an algebraic expression to find the measure of the two angles described below. It says begin by letting x represent the degree measure of the angle's complement. So x equals the angle's complement. Okay. Then the part that I'm going to find here in a moment that we're going to define is then what we call the angle. Does that make sense? Okay. If they're telling me the angle, because we got two angles, right, to make complements. If x is the angle's complement, then the other thing that we're going to find in a moment, the other variable that we're going to find, must be the other object, which is in this case the other angle. But it says the measure of the angle is 20 degrees greater than its complement. Well, if its complement is x, how do I write 20 degrees greater than x? X plus 20. Okay, or you can go 20 plus x. But it's got to be greater than, so like I think I heard 20 times x. If you go 20 times x, that phrasing would be that it's they would probably say it's 20 times bigger. Okay. The phrases greater than, more than, those elicit addition. Less than, difference, those things elicit subtraction. So we've got those two things right now, x and x plus 20. Now, the overall relationship that's going to, so now we've got our variables. We got to figure out what is the relationship that links them. And they're talking about complements, right? Okay, what are complementary angles? What's the relationship? They add up to 90 degrees. So I'm going to have x plus x plus 20. That's one angle. There's my second angle. And they should add up to 90 degrees. So that's 2x plus 20 equals 90. 2x is 70. So x then has to be 35, right? Because I'm adding these things together here. So you got an x, because by definition, complementary angles are two angles. So here's angle number one and angle number two. By definition, complementary means those two angles should add up to give me 90 degrees. So I got 1x plus another x, and that's going to be my 2x. So then we get 35 for x, and if I add 20 to it, I get 55, right? Those add up to 90, okay? A lot of times people get confused. They type in like 55 for x, and they type in 35 for the comp, because when I type in 35 here as my answer, I think the question then generates another box and asks you for the other angle. They get those flipped, okay? So just be careful with that, because they are telling you what your variables have to be there in the problem, okay? I think there's a question that says there are supplements. That's the same type of question. You just change the 90 to 180. You guys remember doing questions like that last year where they give you an algebraic phrase and you change it into words, or they give you a word phrase, you change it to algebra at the beginning of the year? The purpose of that was for things like this, because a lot of our statements in geometry, we're going to take an algebraic phrase in words and put it into an algebraic phrase in variables and operations and that sort of thing. Yes? So that would be the first one we answered was 35. So the other one would have been the one that we labeled as just the angle. So when I found 35 as x, that was the one that they told me to start with. And they say here the angle then is 20 degrees greater than that. So I take the 35 and I add 20 to it, and it gives me the 55. There's some others on there that are similar to that. If we have questions on those, I'll let you guys, so now we've seen that one, I'll let you guys kind of fight through the other one that is similar to that. And if you have questions over that, we can talk about that again tomorrow before it's due. You have a question now? 29 times greater. Yes, yes. Let me see. So here it says the measure of the angle is 80 degrees greater than, so that would be greater than is addition, right? Okay. See if we can 80. So these are all. So question 14 is all going to be ones that say greater than, and they just change the quantity. 13, that's the one they're saying 4 times greater. So 4 times greater means then you're doing the multiplication. Okay. And there, the supplement, instead of 90, you're saying the supplement then would be 180. So you're going to add to 180. So here you're going to find one to be x and one to be 4x. You're going to add those together and set them equal to 180. But like I said, we can talk about those a little bit tomorrow. I do have the need to go over half of section. We're going to skip section 1.6. I think that section falls in a better area later on. But we'll do half of section 1.7 today. We'll do the other half tomorrow. Okay. We'll review on Thursday, and then Friday we'll have a test over chapter 1. But we're talking about midpoints today. Okay. But what happens, guys? And this is every single chapter is going to have a component to allowing us to work inside the coordinate plane. When I say the coordinate plane, I'm talking the XY axes. Okay. And there are some, and I'm actually of this kind of school of thought. I think everything we do, even though we don't necessarily draw it or represent it in a lot of the pictures we do, every single thing we do in the geometry class, there should be like an X and Y axis kind of in the background. Okay, and everything we are doing is based off of that. Okay. Or can be understood using that, and the information that you guys already know about graphing points and lines and that kind of stuff. Some geometry classes and courses are designed solely to investigate all of our rules and postulates and relationships through the use of the XY axis. Okay, we don't do that necessarily, but it does pop up at least one section for every chapter. So that being said, and you're going to hear me say this again, we get to chapter 2, there will be something about working in the coordinate plane. Chapter 3, there will be something about working in the coordinate plane. And what sucks is that there will be somebody who's in chapter 7, and we've seen this thing 6 times, still doesn't know what the formulas are. Okay? So I think knowing, having that foreshadowing, the knowledge of this is going to be around, stick around, might make it more important to you now. Does that make sense? Like if I know that I'm going to be tested over something, people ask this all the time, is this going to be on the test? Well, you ask that because you want to know, is it important for me to learn now, right? Okay. Well, this is going to be around forever, so this is going to be important for us to learn as soon as possible. Okay? It'll make your life so much easier. And it's talking about the midpoint formula and the distance formula in the coordinate plane. Midpoint formula, we'll start with the basics and just working in one dimension. Okay, so just working on a singular number line. If I want to find the midpoint between two coordinates, all I have to do is sum their coordinates and then divide by 2. Okay, and if you think about what that means, if you had 2 coordinates and you add those together and you divide by how many coordinates you had, that's by definition taking the average. So you're going to hear me say a lot of times, if I want to find the midpoint, I'm going to take the average of the endpoints. The midpoint is the average of the endpoints. You see here in this formula, Okay, capital A is the point. Okay, that's the name of that position on my number line. Lowercase a is what we call a coordinate. Okay, and that's going to be obviously a number for us. Okay, B is also a coordinate, or lowercase b. But if I add, you see the formula there to find the location of the midpoint M. All it's doing is it's taking A, that coordinate, it's taking the B coordinate, add together and divide by 2. It's that easy. That's all you gotta do. So if I have, we'll just do this on a GeoGebra real quick. Try to get rid of the y-axis here. So if I have a segment, and we will make that segment blue so we can see it a little bit better. And I put one coordinate at 8, and I put the other one at 18, okay? And I want to find what the midpoint of that is, okay? So one's at 18, one's at 8, okay? We can go, and if we add those together, so what do you get if you add those together? 26, and now divide by 2, you get 13, right? The nice thing about this is that I can actually ask it to find the midpoint of a segment. Click on this segment here. You see it puts C right there. Is it at 13? That kind of makes sense? Okay. We can do that with any segment we want, okay? Now, what becomes usually an issue for people is when we do that with like negative values, but don't let the negatives throw you off. If I go from -6 to, let's say 12, okay, what's -6 plus 12? 6, divide that by 2, you get 3, right? Let's see if the midpoint's located at 3. It looks like it is, right? Okay, so all we have to do, so when we're working in just one dimension. Now, I was showing the x-axis, okay? But the same thing happens if we want to go with something that's vertical. If I want to go with the y-axis. Okay, so if I want to put an endpoint on like 6 and then one on -2, 6 plus -2 is 4, right? Half of 4 is 2. And you can see here that your midpoint would be at 2, okay? So this is one dimension, either just an up and down number line or a left and right number line. Add the endpoints, divide by 2. Does that make sense? Okay. So now, the one thing that we like to do is find midpoints of, let's say we have a segment like that. Now there's not just a left and right aspect to it and not just an up and down aspect, right? We got this horizontal component and we got this vertical component. But what we can do, and we'll prove this maybe in a couple weeks, okay? But I just want to kind of walk you through here the logic of this, okay? If I want to find the midpoint of this segment, what we actually do is we break every segment you draw or construct in the coordinate plane is the hypotenuse of a right triangle. And what I mean by that is I'm just going to make this so that it will readjust itself no matter what I make this segment. So just give me a second here real quick. All right, so every segment you draw is the hypotenuse of some right triangle. So would you agree that that would get me from A, if I'm going to go from A to B, that at least gets me in the horizontal direction to where I need to go from A to B, right? Then I would follow that up with going from C up to B. Is everybody okay with that? So I'll make that one blue. All right. So no matter what I make with this red segment, would you agree that there is always a right triangle? No matter how I make this red segment, is there always a hypotenuse of a right triangle? Okay with everybody? So let's find the midpoint. Let's figure out how we can find the midpoint. The way we're going to find the midpoint, and you guys are aware of this algebra. You've seen this in the past, the way we're going to identify this stuff. Because we have multiple x values and multiple y values here, and I don't want to, well, maybe we will. Let's do it this way. Let's use some just basic ordered pairs here, okay, with specific values, and then we'll see what happens with generic values. But this ordered pair here for A is 4, 6. Okay. This ordered pair here for C is 16, 6. This ordered pair here for B is 16, 12. Okay. So I got that information in there. What I want to do is I want to find the midpoint of the red segment. But what's going to help me is the actual midpoint of the horizontal and vertical segments. So if I'm looking at this horizontal segment, okay, the points of that are going to help me, or the coordinates of that are going to help me find the midpoint of this horizontal segment are the 4 and the 16. Okay? If I add those together, what do you get? 20. Divide by 2, you get 12. Or sorry, 10. Sorry, you're right. So 10, right? 10, if I plot 10 right there, does that look like it is the midpoint of that purple segment? Okay. The 6 doesn't matter to me because they're all horizontal, right? Those 3 points are collinear, so they're all going to have the same y value. Even if I took that number plus that number divided by 2, it does still give me the 6. Okay. Now I'm going to do the same thing for the blue. Okay. But when I do it for the blue, because it's a vertical distance, I'm talking about using the y's now. So it's 12 plus 6. 18 divided by 2, 9. So 9 would be right there. So I'm going to have x value of 16, y value of 9. Okay. And you might not be seeing what is actually going on here or the purpose of this yet, but let me draw this in real quick. Let me write x equals 10 in, and it's going to draw me that line right there. Does that make sense? I'm going to draw y equals 9 in, which I don't think I typed 9. Can't see it. Type 0. Y equals 9 gives me that line right there. Where do those two lines intersect? Right there at the midpoint of A to B. Does that make sense? So the midpoint of A to B, that point right there, okay, we took as, remember, so this x value, this point here is going to be, to get from 0, 0 to that blue point, you go over 10 units and up 9 units, right? So the ordered pair is 10, 9. But think about how we got that. We took the average of those x's, average of x's, and then comma that with the average of those y's, didn't we? Okay. So when I want to find, and we'll be more specific in general with the formula here in a moment, but if I want to find the midpoint of any line ever, okay, whether it be horizontal, vertical, or something like this red one, Okay? Anywhere in the coordinate plane, to find the location of the midpoint, you add the x's of the endpoints, divide by 2, comma, add the y values, divide by 2. Okay? And this is the logic behind that. Okay? So what we end up doing, and this is what I was kind of hesitant to show at the beginning, is if I take out all my numerical representations here. So if I take out, let me get to the, there we go, graphics, x-axis, take the numbers away, y-axis, take the numbers away. So now you don't know, even if I'll take the grid away to make it a little bit more difficult to count or to guess those things. So if I've got that image right there, do you guys remember? So I'm giving you this red segment. I'm giving you point A and point B. Do you remember that point A can be written in Algebra 1 as x1, comma, y1? Remember that when we talked about slope? Point B would be x2, y2. Then when I want to find my midpoint, okay, my midpoint down here is going to be, like I said, we take the average of our x's. So it's x1 plus x2 over 2, and then it's the average of the y's. So it's y1 plus y2 over 2. And that's our generic setup. That's our formula that will allow us to solve for the midpoint of any segment we want. So I'm highlighting the coordinates on the axes. Those would be the respective x1, x2, y1, y2 spots on the axes. Is that okay with everybody? If I go, we can go even more detail with this. This point here, would you agree that C has the same x coordinate as B? So C is going to be an x2, and it has the same y coordinate as A. So that ordered pair would be x2, y1. If I want to find this point right there, which helped us find the midpoint, remember, we took x1 plus x2 over 2, and then we could take y1 plus y1 over 2, but what is y1 plus y1? What's that give me? How many y1s you got? 2 y1s, right? If I divide that by 2, does that just give me y1? So if you remember, when we did the specific question, those were 6's, right? And that should make sense all across this horizontal line. That number, that y coordinate, that y coordinate, that y coordinate should all be the same. This one here was x2, and it would have been then y1 plus y2 over 2. And then the intersection of those lines means that any point where they intersect, okay, they're going to have the x coordinate of this line and the y coordinate of that line. And that's where we get that there. Okay, I don't like to, you're going to find this out, and some people are going to hate this, but I do not like to give you something. I don't like giving you a formula like this or a picture like this and say, memorize that formula, and you have no logic or understanding of where it came from. Okay, so I'm big on deriving formulas, showing you formulas, and making sure that we can, at some point, I'm not saying this year, but at some point, reproduce formulas. Okay. Just some examples here. There's two types of examples I want to go through before we get out of here. First one, pretty straightforward. They give you the endpoints and they ask you what is the coordinates of the midpoint. Okay. So what I like to do, just so that I like to be very specific with my work. I'm terrible at organizing my work. Okay. You've probably recognized that with some of my stuff where it's all over the place, and I'm aware of that. I know that. I'm self-aware of my faults. Does that make sense? So I know that it's created me problems in the past, especially when I was a student. So the way I got around that, or to fix that so it wasn't hurting me, is I became very detailed with my labeling. Okay? So I might have things all over the place on my paper, but everything is labeled so I know what is what. Does that make sense? Okay, so I apologized for that. but I will make sure that I label things very well so that you can follow things. And I would suggest that maybe you do the same thing. So I always start with my formulas, okay? Especially if I just learn them. So I'm going to write capital M. This is the way I write things for a midpoint. I'm going to write X, and then I write a subscript M, Y, subscript N. And all that means to me is that what is going to go in those spots is the X and Y coordinate of the midpoint. So that subscript, that lowercase m in the bottom corner, is just a identifier for me to tell me that that ordered pair is going to be the midpoint. Does that make sense? Because there's going to be 3 ordered pairs here, right? You got 2, -4, you got 7, 5, and then we're going to actually have the midpoint. When I'm done, I want to remind myself just by glancing and not having to go through the work entirely again or look at my picture. I want to look at my answer and know, oh, that's the answer for the midpoint. These other 2 things were the endpoints. Okay? So I always write the formula this way, and this will help in the next example that we do as well. But then, obviously, the x1 plus x2 over 2, y1 plus y2 over 2. So I write my formula. Okay? I am then going to say, so I use capital M for midpoint, just to label it. It's the easiest thing to do, I think. Now I'm going to go in and figure out what I want x1, y1, and x2, y2 to be. Okay? It is the same as slope in the fact that it doesn't matter. Okay? If you want that one, I usually go the first one I see left to right. So that one is x1, y1, x2, y2. Just plug them into your formula. So we're going to have 2 plus 7 over 2, and then y1 is -4 plus 5. So y2 over 2. So now the midpoint located x comma n, or x sub m, y sub m. That's going to give me 9/2, comma 1/2. 9/2 is 4.5. So there's 2, 3, 4, 4.5 be about right there, and then 1/2. I always like to, especially if they provide me a picture, do a quick sketch, a quick justification. Yeah, that looks like it's in the middle, right? Okay, if it wasn't on the line, I know I did something wrong. But that's how you find the midpoint of a segment in the coordinate plane. Is that something we can do? Just, it doesn't matter. I go left to right, so the first one I saw when I read this graph is this point F down here. So I'll let that one be x1, y1. Okay, but you would have gotten this because addition is commutative, so you can flip them back and forth, right? So if I would have let this one be x1, y1, the only thing that would have changed is that would have been 7 plus 2, and that would have been 5 minus 4. But I still get the same 9 and 1, right? So it doesn't matter. Slope's the same way. It doesn't matter if I go from slope from F to E or E to F. The slope of that line is still going to be the same. Questions on that? So the reason I like to look at this is because now I know X coordinate of the midpoint correlates to 9/2. The Y coordinate of the midpoint correlates to 1/2. Okay? If I just had a bunch of ordered pairs like that one, and then that one written on my work or on my paper, and we're going to have a discussion about it, we're going to talk about it, I'm going to use that in somewhere else, I need to then think about, okay, which one was the midpoint, which ones were the endpoints, that kind of thing. All right, so the next example is more difficult. Yes? Yes. So 9/2 is, like if I put it as a decimal, it's 4.5. And 1/2 is 0.5, right? So I always go from 0, 0. So this is my X direction, this is my Y direction. So I'm going to go X direction first, so count out 4.5, and then follow that by 1/2. This one I think is more difficult, and I've got the work here. So if you printed this out, this stuff is already there, but I don't want to do it with you like it's already there, so let me white it out. All right. So here's a question. So they tell you one endpoint, and they say up there that the endpoint is C. and they tell you where the midpoint is. And then they want you to come up with where the other endpoint is. Does that make sense? So they're telling you the middle and one end, and you got to find the other end. Now, I'm going to give you a technique here. We're going to do this real quick that works only half the time, okay? And it only works when we have really nice values in our system. If I go back up to this example real quick here, would you guys agree that if I travel up that distance right there and then over that distance, and then I travel up again, so that vertical distance right there is same as that one. Does that make sense? And then over a horizontal distance, that dotted distance there is the same as that one there. You agree with that? So that midpoint is structured in a kind of a symmetric position in regards to rising and running on that line. So let's use that idea. If they say we've got this point here at negative 5, 7, my midpoint is at negative 2, 1, and I want to go from C to M, so I'm dropping down 6 units. Does that make sense? So dropping down 6 units. And then I'm working over 3 units. So I'm adding 3 to that. Okay? Well, if I want to find my other endpoint then, I need to drop down 6 more units. Does that make sense? I need to repeat what I did right here. So if I go from negative, so my current location would be at negative 2, comma 1. If I drop down 6 units, where's that going to put me on the y-axis? Negative 5. Okay? So negative 5 would be my y value. And then I need to, so I'm at negative 2, I need to move over 3 units because of what I did right there. So if I'm at negative 2 and I move to the right 3, where's that going to put me? 1, right? Is that a quick way of counting to get my other endpoint? Okay. Now that works because those are integers. Okay. Those are whole numbers, positive or negative, right? That would not work if I gave you fractions as your endpoints, or if I gave you just variables as your endpoints. Okay. So I want to go through the actual mathematical portion of this with formulas, because we always should have, you guys did slope last year, rise over run, right? You would count the rise, you'd count the run, correct? But did you have a formula that went with it as well? y2 minus y1 over x2 minus x1? That formula will always work. That formula will never fail you. The counting will fail you, okay? Especially when we start moving away from whole numbers or integers. So let's approach this using our formula. So the midpoint, which is x sub m, comma y sub m, let's write my formula down. So you go x1 plus x2 over 2, and then y1 plus y2 over 2. The midpoint, so they're saying m is the midpoint. So right here, that's and this is the reason I use the x sub m. That is the coordinate of my midpoint, the x coordinate. This is my y coordinate. This over here is one of my endpoints. And it doesn't matter again. That is either x1, y1 or x2, y2. It doesn't matter which one you let it be. Okay? Now, look at your formula. Do you have an xm or x sub m in your formula? You have a y sub m in your formula, right? You have an x1 and a y1 in your formula. Let's plug those things in. So x sub m was negative 2. Y sub m is 1. X sub 1 we said was negative 5. X sub 2, we don't know what that is. That's what we're looking for. That's the x coordinate of the other endpoint. Divide by 2. Y1, we know that to be 7. Y2, we don't know. That's the other coordinate of the other endpoint. Divided by 2. Okay. So I'm going to move back up and show you the comparison of what we talked about when we were done up here. Remember I highlighted this one yellow and said that links to the 9/2? It was the x coordinate of the midpoint. This is the actual value of that x coordinate. So down here, it's the same thing. That is the x-coordinate of my midpoint. This is another interpretation of my x-coordinate of my midpoint. They should be the same. Does that make sense? If they're the same, I should be able to write this. Is everybody kind of on the same page with that? Those two values, even though one is an algebraic expression, they should be identical. So I set them equal, and I should then be able to solve that. What about this one? That y value should be the same as that y value. So I'll set those equal as well. So I'll say 1 is equal to 7 plus y sub 2 all over 2. Now, if you have an equation, let's solve this black one. If you have an equation that has a fraction in it, you want to get rid of that fraction as soon as possible, right? What can I multiply everything here by to get rid of that fraction? Get rid of that 2 in the bottom here. I multiply by 2. So we get negative 4 is equal to negative 5 plus x sub 2. I'll add 5 to both sides. And I get 1 is equal to x sub 2. Over here, it's the same math. Multiply both sides by 2. Get 7 plus y sub 2. Solve for y sub 2. Subtract 7 from both sides. And I get y sub 2. Your ordered pair is x2, y2. So it's 1, negative 5. Is that exactly what we found by counting? Okay. Now, you might argue, dude, that was way too long if I could get the answer by counting, right? If you're a person that only counts, you will get questions wrong on the test or quiz because I will generate questions that eliminate your ability to count. Okay? We have to be able to do that for me. The reason I do that, I'm not trying to be a jerk. Okay? The end of course exam asks you to do that. Okay? So I don't do things, or it has asked you to do that. I don't do things in class just to be a turd, to be a jerk, to make you work harder than what's necessary. I do it because I know what you're going to encounter in the future and what you're going to need to be able to do in the future. And that's the kind of the method behind my madness. Okay? Yes. Say it again.
Which formula do you use to find endpoint D?
This one here. So this stuff up here. Because now that, because this was my midpoint formula, right? So if I know what my midpoint values are, what the coordinates are, so I plug those in here, so that yellow one and that yellow one should be the same, right? So I set those equal to each other. And the same thing for the green ones. Does that make sense? Did I answer your question? I will open a section of 1/7. So 1/7's homework is going to be in two sections. There's one focus on just midpoints, and there's one focus on distance, which we'll talk about tomorrow. I'll open the midpoint one today. It'll be due, let's say, Tuesday, so it'll be due Thursday. And we'll pick up from there tomorrow.